this session we are going to explain, or we are going to discuss about what is priority scheduling. So we have discussed first in first out and shortest job first. Now we will be discussing priority scheduling, and we have one more thing called as round robin algorithm, okay, or round robin scheduling. Okay, so what is priority scheduling is? Priority scheduling is a type of scheduling algorithm where each and every process, if I consider process 1, this process will be attached with one more information called as priority, which will be giving preference. So which process has to be executed first and which process has to be executed next. Like that, we are going to give some priority values. Those values will be attached with each and every process that has been created. So that is nothing but by using that we are going to schedule the execution, which is used in priority scheduling. In this priority scheduling, so we need to discuss one more thing, like what we have discussed in the previous things, like shortest job first. Shortest job first algorithm, or this scheduling algorithm, will be considering or will be used to, you will have some additional function of identifying the burst time. Okay, so for every process that has arrives, so for that process it needs to identify the burst time and next possible burst time which has, or the process which has arrived, and it needs to compare the shortest burst time each and every time. Whenever a new process arrives, it needs to identify the shortest burst time every time a new process arrives, so that we can execute the shortest process or shortest job first in this algorithm called as SJF. So this process that we are going to use in SJF method, when we come across priority we are not going to use that. Instead of that, we are going to assign some numbers to the process which will be representing the priority. So which will contain something like minimum priority as well as maximum priority. So minimum priority is or low priority as well as high priority. Low priority is whichever process is having the lowest number, like from this list the lowest number is 1. So that will be given the highest priority. So in the sense, whenever you see the number 1, that process will be executed first. So high priority or maximum priority is whichever is having the highest number. Say for example 4 will be having the highest priority. So that is the way we are going to use for executing this priority scheduling method. So usually we will be using the method called as lowest priority. Whichever the process is having the lowest number, that will be having the highest priority. Okay, and other than this, suppose say in case of something like this, you will get process 1, process 2 and process 4, both the processes having the same priority. In this case, we are going to use first come first serve, or so whatever we consider, that is first in first out, first come first serve. That is, according to this, P1 has also having the priority as 1, P2 is also having the priority as 1. So both this P4 and P2 both is having the priority as 1. In that case, we are going to consider P2 first and later we are going to consider P4 according to the time of arrival or according to the given in the table. Okay, so that is about priority scheduling. So priority scheduling will face some problems in the sense, for example, if I give this process as P3 as 4, now I'll get P1 to P10 processes. All the 10 processes will be having lesser priority, like 2, 3, 1, 1, 1, 2 or something like that. In this case, this process 3 will not be executed until all these processes are completed, because its priority is higher compared to that of this P3's priority, which is 4. So all the other processes is having higher priority, like 2, 3, 1, 1, 2, 1, something like that. So until this 10 process or every process is completed, this P3 will be in the waiting state itself. That is nothing but starvation. Okay, so what is starvation is, if any process is waiting in the ready queue for a longer time, then that process will undergo this situation or this stage called as starvation, where it is waiting for CPU for its execution. Okay, so that is starvation. To avoid this starvation, what is the solution is? There is a solution called as aging. Aging in the sense, as the process time of waiting increases, the priority can be increased, or the priority of the process can change based on the aging of the process in the ready queue. So that is one solution where we can execute all the process in less amount of time. Okay, so that you need to just understand what is the meaning of that and what is how you are going to use that in a priority queue. Okay, so that is about priority queue. So generally understand priority queue, or this priority queue scheduling, what we are going to use is, in this scheduling process, every process will be having a number or a priority number that will be attached with every process. Once the execution starts, or once the process starts, process has been executed by the CPU, it is going to select the process with highest priority. Whichever process is having the highest priority, that particular process will be selected for execution. Okay, now if this is the process, and if I want to write the chart using let us say priority scheduling, so then we are going to start with the chart, and by default, if they have not mentioned any arrival time will be, by default it will be 0. Okay, in the chart or in the table, if they have not mentioned arrival time is by default 0. Now, so we have four process. First, process 1, which has arrived at 0 millisecond, and you can see we have priorities 1, 3, 4 and 2. So since we will be considering low priority, in the sense whichever process having lowest number, that will be considered as the highest priority. The lowest number is 1. So in the given list, first process that will start execution is P2. Okay, and this is non-preemptive. Okay, so that we have discussed preemptive and non-preemptive. So this problem will be solved based on non-preemptive. That also they are going to mention. So this is non-preemptive. So once the process starts, until it is completed, other process will not be selected. So P2 has started, it will be having burst time of 4, it will complete at 4. Next priority is given for P4. So P4 will start, P4 will consume what is the burst time it will consume? 2. So it is nothing but 6. Next process it will start as P1, it is going to consume 8 burst time. So that is 6 plus 8, which is nothing but 14. It is going to end at 14 milliseconds. And at last we are going to have P3, which is going to have the burst time as 6, which is nothing but it is going to end at 20. Okay, so this will be the chart. So the chart for the given table. For the given table, we are going to have the chart like this, where it will start at 0 millisecond and it will end at 20 milliseconds. Okay, so according to that, you can just calculate waiting time, turnaround time, and response time, as well as throughput. Okay, so the same example what we have done previously, the same thing we will be doing again. Waiting time for P1 will be, it has started at submitted at 6 milliseconds, but it has arrived at 0, so it will be 6. P2 also, it has started at 0 and arrival time was 0, it will be 0. P3 has started at 14, so and arrival time was 0, it will be remain 14. So again P4, it has started at 4 milliseconds, arrival time was 0, it is 4. So we will just calculate this, we will have 24 by 4, that will be our waiting time. So and again turnaround time of completion is P1 has completed at 14 milliseconds, arrival time was 0, which is 14. P2 is time of completion is 4, time of arrival is 0, so we will have 4. P3 is time of completion is 20 minus 0, which is 20 again. P4 is time of completion is 6, arrival time is 0, again we are going to have 6. So it will be like 40 and 44 by 4, that is 11 milliseconds will be your turnaround time. Okay, so response time will be similar to that of waiting time, you can calculate. And throughput, if we have a total of 4 process which has completed in 20 milliseconds, which is nothing but 0.2 milliseconds. Okay, 0.2, that is 1 by 5. So 1 by 5 milliseconds or 0.2 milliseconds will be a throughput. Okay, so this is one more type of algorithm or scheduling called as priority scheduling, where each and every process will be combined with or given with a number called as priority. So according to which we are going to draw the graph. and I'm going to send two problems based on shortage of first with pre-emitting and priority scheduling with both pre-emitting and non-pre-emitting. Just try those problems. In the next class, we are going to discuss the last method called as round robin algorithm. With this, we will complete all the problems from your second chapter after completing round robin algorithm. Okay, thank you.